Friends, Know Your Device lecture series. This is the fourth lecture of this Know Your Device series, and in this lecture I will talk about Varactor Diode, which is also known as a voltage variable capacitor, Varicap, Epicap, or by various names, and it utilizes the reverse biased junction capacitance of this PN junction diode. So let us understand how this junction capacitance affects the working of this voltage variable capacitor, or also known as a Varactor diode. Well, here I have shown the structure of this voltage variable capacitor, that is the Varactor diode. This is the depletion region. On the right side of this junction there are positive immobile ions. On the negative side, P side, there are negative acceptor ions. And in the P region there are a large number of holes. In the N region there are a large number of electrons. So this depletion region acts like a dielectric, and P and N regions work like capacitor plates. So this ordinary PN junction diode is just like a capacitance. Now this capacitance, when the diode is working under reverse biased, is known as the junction capacitance, which has a value of 2 picofarad to 100 picofarad. So the junction capacitance is small, and it dominates under reverse bias, and it is a voltage variable capacitor. I have shown here the variance of this capacitance with the variable reverse bias. We can see that this reverse capacitance is decreasing with increase in reverse bias voltage. Okay. Now this is the symbol of this Varactor diode. Since this Varactor diode is just like a variable capacitor, so this is the voltage variable capacitor symbol for this Varactor diode. Now this capacitance of this junction capacitance of this Varactor diode is basically voltage variable, and it also depends upon the doping profile or the doping level of the junction. What kind of doping is there in case of this diode? So here I have shown two different types of doping profiles. The first one is the doping profile which is normally used for ordinary PN junction diode, and it is known as the abrupt doping profile, which is also the step graded junction profile. In this profile, the doping level is uniform throughout the device. So on both sides of the junction you can see that on P side as well as on N side, the doping level is uniform or constant. Here it is the junction, and this is the distance from the junction. So as we move away from the junction, there is no change in the doping density of the PN junction diode, or this Varactor diode in this case. So this is the normal case of ordinary PN junction diode, abrupt doping profile. Now here another type of doping is used, which is known as hyper abrupt doping profile. In this case you can see that doping is highest at the junction, and it is gradually decreasing as we move away from the junction on both sides, on N side as well as on P side. Now we can see that in both these cases the capacitance of the junction, this Varactor diode, basically depends upon the reverse voltage in different manner. Here you can see that Cj is directly proportional to the minus half power of Br, that is the reverse voltage. So if we increase the reverse voltage, there will be a decrease in the junction capacitance like this, Cj proportional to Br raised to the power minus half. Whereas in this case of hyper abrupt doping profile, you can see that Cj is proportional to Br raised to the power minus alpha, where this alpha can be 1 by 3 to 1 by 2 in this range. So okay. Now these two doping profiles will lead to a capacitance variation in different manner. In this first case, that is the abrupt doping profile, Cj varies from 3:1 to 4:1. That means the maximum capacitance may be at most 4 times of the minimum capacitance. But in this case you can see that Cj can be up to 10:1. So that means the maximum capacitance can be 10 times the minimum capacitance of this diode. This abrupt doping profile leads to high quality factor for this device, and which means the low signal loss for this case. And in this hyper abrupt doping profile, you will see that the device will have a low value of quality factor. Now quality factor is given by this expression, where Q is 1 upon 2 pi f Cj Rs. This Cj and Rs can be seen here in the equivalent circuit of the Varactor diode. And the fourth point is that this doping profile, that is the abrupt doping profile, is suitable for the use of Varactor diode in case of high frequency operation, because this FCC, that is the capacitive reactance, is given by 1 upon 2 pi Fc, and at high frequency you will see that this reactance will be small. So this doping profile is suitable for high frequency operation of Varactor diode, whereas in this case hyper abrupt doping profile, this is basically suitable for the requirement of wide tuning range. Wide tuning range because the variation of Cg is up to 10 times. So we can get a large frequency variation in this case between the minimum frequency and the maximum frequency. So if it is Varactor diode is used as a tuning capacitor, then tuning circuits of certain devices like TV receivers, radio receivers, then this hyper abrupt doping profile will be more suitable compared to this one. This tuning frequency Fr is equal to 1 upon 2 pi L Cj, where Cj is this. So this junction capacitance is voltage variable. So if we vary the reverse bias voltage, we will get this variable frequency, and this property is utilized for the Varactor diode used as TV tuners in TV and radio receivers. So this is basically the important semiconductor device, which is actually a PN junction diode utilized for its voltage variable capacitance property when operated under reverse bias. So thank you. Hope you will enjoy it.